Hi guys, welcome back to the channel. So now we are going to be looking at the weekly's second question, weekly's contest second question, which is maximum happiness of a selected children. We are given an array of happiness of length n and then positive integer k, and then we need to pick the k children out of n children. So there are n children, total n children, and then we need to pick k children out of them, and then we need to return the maximum sum of the happiness values that can be selected from a selected children of k out of n children. And then one more thing is, whenever we in each turn we are going to pick a child and then we are going to add it to the happiness value, and then at each time we do that, the other children's will be decreased. The other children happiness value is going to be decreased by 1. So that's what they are stating. And then one more thing is, the happiness value cannot become negative. That means, let's say the happiness value is 2, and then the turn is third or fourth, and then whenever we are doing the fourth turn, the value should be decreased by 3, but then 2 minus 3 is minus 1, so it cannot become negative. It can only be decremented only if it is positive. So if there is a 1, then we are going to decrement that. If it is not a 1, then if it is 0, then we are going to keep happiness as 0 itself. So we will not be decrementing if it is negative. So let's see the approach. Let's consider this particular example where we have this happiness array. In this array, the array can be in any order. It can be 3 to 1 and then 1 to 3, and then it can be in any order. So let's sort this array so that we'll get the maximum happiness at the right side of the array, and then the less happiness will be at the left side. After getting After getting the arrays in sorted order, we need to pick k children out of this so that we'll get the maximum. So when can we get the maximum? We can get maximum when we choose the maximum element which is present. So that will be on the right side. So we'll try to come from here, and then we'll try to see whether this sum this sum can be added into the answer, and then the count becomes whenever the count is less than k, we are trying to increment the happiness value, and then we are going to use it. And then and one more thing is, whenever we do one turn, the happiness gets decreased. That means, suppose let's say I use 3 as a first, then for the next time the happiness is going to be 0 and then 1. And then one more, if I consider one more case, which is going to be like, I'll be doing the same thing, and then I'll be using the last element for the next turn. For this will not be there, and then this becomes 0 itself. Why? Because it cannot go less than 0. So we'll be doing that. So the happiness will be 3 plus 1, which will be 4. So we'll be returning 4. So instead of decrementing this array like all the elements which are previously present, we can use this count variable, so that whenever each turns happen, we'll increment the count, and then instead of decrementing, we'll say the happiness minus count is going to be the real happiness. So we'll do the same thing. So let's see the code. So we'll sort the array so that it will be in sorted order, and then all the happiness which is maximum will be at the right side. And then from right side we are going to increment the sum value, and then we are trying to count the number of turns which already happened. So the count is initially 0, and then whenever the happiness minus count is greater than or equal to 0, then we are adding it to the sum, and then we are incrementing the turns, and then we are decrementing the index value, so that we'll move to the next previous happiness, and then we'll return the sum. For this, the time complexity is going to be n log n, and then space complexity is going to be big O of sort. Whatever the sort a space takes, it will be taken. So that's all for this video. Let's move on.